Okay, so let's finish our discussion from yesterday. So let me just prove to you why this reflection is a shift to the right, or I'm sorry, and a reflection over x equals 2. So if you plug in this original natural log of 2 minus x into your calculator, in for y equals, just like that, just like the original one says, and then hit graph, you're going to see right here, of course you're not going to show your vertical asymptote, but your vertical asymptote has moved to the right to x equals 2, and it's also reflected over that vertical asymptote of x equals 2. So if you have a situation where you have a negative inside the argument, that negative is going to reflect it over the vertical asymptote, and in this case, x equals 2. So then I want you to plug this one into your calculator to look at what happens if we have the natural log, obviously base e, of x squared. What does that do? So let's go to here, clear that out. I'm going to do natural log of x squared. So that's what I've plugged in. Look what happens. Interesting. So I can actually choose now, and again, you have this vertical asymptote of x equals 0, but because of the x squared, I can actually now choose negative values for x, where we couldn't take a natural log of a negative before, but because I'm squaring it, it turns out to be positive, and it ends up looking like this funky, almost like a bird in flight kind of design. And so the domain for this is now all real numbers with the exception of one value, and that's your vertical asymptote. Still hasn't changed. You still can't take the natural log of 0. So your domain is going to go for this one, negative infinity to 0, union 0 to positive infinity. Our domain for this one, because it got reflected, our domain here is actually going to be negative infinity all the way up until we hit 2. And the domain for this one, because we've shifted right to, that means that we're going to start at 2. So our domain here is going to start at 2 and go to positive infinity. All right, so then we have this word problem, human memory model. So students participating in a psychological experiment attended several lectures on a subject. At the end of the last lecture, Mr. Gleason forgot the T, and every month for the next year, the students were tested to see how much of the material they remembered. The average scores for the group were given by the human memory model. And so this is the equation, if you will, and then T is in between 0 and 12, and it includes 0 and 12, so that's your 12 months. So T is your time in months. So question A is asking what's the average score on the original T equals 0 exam. So all we're going to do is plug in and find f of 0. So I've got 75 minus 6 natural log. Make sure that that looks more like an L than a 1 of 0 plus 1 equals. And all you have to do is just plug this in your calculator. And if I were you, take your y equals and put this in your y equals. So I'm going to put 75 minus 6 times, and you don't really need the times, but I'm going to put it in there anyway. Instead of t, I'm putting in x plus 1 in parentheses. So then all I have to do is go to my table of values and plug in, there's my 0 plugged in. So 0 is going to give me 75. So over here I get 75. And so then f of these next 3, I'm going to put in 2 months and then 6 months. And I'll plug those into my table. I'm gonna plug in 2 and 6, and let's see what we get. So 2, whoops, I'm gonna go back up there. 0, 2, and then 6. So my 2 was 68.408. So we're gonna just round that to 68. And then for 6, we had 63.325, so I'm gonna round that to 63. And that's it.